So yesterday you received the introductory version of this lesson, and I'm just going to kind of dig a little bit deeper here. I shouldn't have to talk about this much more after this short lesson. So you know the gist. I gave you the warm up yesterday. I explained to you that there are three types of systems. There's systems where the lines can cross. There are systems where the lines are parallel, and then there's systems where the lines just sit right on top of each other, right? And so we're just going to take a little dive into that. The difference between what we talked about yesterday and what we're going to talk about today is there's just a little bit more math maybe on the front end of these. So the one thing I did realize that I left out of this are horizontal and vertical lines. So I may have to go back and readdress this at a later time. But for now, we're going to go through four examples. So here's your first system. And so, you know, because you were here yesterday, the idea is that we're going to get the graphs done. We're going to graph the two lines, and then we're just going to make an observation. And our observation is going to be one of three things. Either we're going to name the point where they cross, or we're going to say, hey, look, they're parallel, there's no solution, or we're going to see that they're the same dang thing, and we're going to say infinite solutions. It'll be it can't be anything other than that. There's literally nothing else that could happen with two straight lines on the same graph. So, yeah, Joe. Yeah. Yeah, so I haven't gotten to that part yet, but just so you know where we're headed, we have to graph these. So I need, so I'm going to graph two equations. I'll kind of scoot this one. Oops, didn't mean to do that. I'll scoot this one up and kind of over here. So let's get to the first one, the one on the left. How would you solve the one on the left side of the curtain? Yeah, you could divide everything by -1, totally. You could also have them switch sides and then the y becomes positive. Like at this point, you know, you've done this before. So if I divide everything that I see by a -1, like this, then the problem's over and I get y equals -2x plus 4. And we would all agree that that line is now ready to graph, right? Okay. How about the one on the right-hand side? What's a good move here? I do have an opinion on this, but I could be swayed. So what would you do? Yeah, Gunner? What? Okay. Do you know that that'll make it negative? Are you okay with that? Okay. So I'm going to go ahead with this. I generally don't move my Y if he's already positive, but I'm going to just go with what Gunner said. So Gunner says, I'd rather take this 2Y and just kick it over to the other side. No issues. Like we're all big kids. We've done this before. So if I move him across, he becomes, unfortunately, -2Y. No big deal. And then on the right-hand side, I am going to rearrange the 4 and the X because we like it the other way. So I'm going to take the positive X and put it first and the positive 4 and put it second. Kind of like that template, that structure, right? And now what do we have to do to finish the job? Divide everything by -2. All right. This is all something that you should, in theory, know how to do by this point. You know, is that a guarantee? No, not really, but it's worth a shot, right? So we have y equals. Here we go. Don't say -2x. What's my x term going to be? -2x. Oh, literally, don't say -2x. Say that again. Correct. So it is -1 over 2x, 1/2 of x. And then what's the y-intercept going to be? -2. So just -2. Tried to express to you when we first learned this how this wasn't going to go away, and it's just not. We're going to see it with this. We're going to see it with inequalities. Like it's just never going to go away. Your ability to get y by itself is pretty important. So we okay? Good. So what we have now is two equations that are ready to graph. I shall call them Mr. Yellow and Mr. Green. And let's start with Mr. Yellow. How do I begin my graph with Mr. Yellow? Go up 1, 2, 3, 4. And what's his slope? Perfectly spoken. Down 2, right 1, down 2, right 1, stuff like this. And I know that that's probably tricky for you on your notes page, but that's that. And then you graph the line. And step one is complete. Okay, how about Mr. Green? Where do I start my journey with that guy? Down to. In this class yesterday, I saw an example of why it is so important to not say -2. I had someone yesterday who was starting their graph on this axis. So I'm just telling you, I am the way I am for certain reasons. Okay, so we're going to say up 2, down 2, up 5, down 4. Never just say a number. And what's the slope?
Down.
Down 1, right 2, or you could go up and left if you prefer. Either way, it's like it's all going to come out in the wash. And then you graph your line. And what's the upshot here? Like, what's the ending of this?
One solution.
There is one solution. I agree. So I like to circle mine. You don't have to, but I like to say, there it is right there. That's the point where the lines cross each other. What's the name of that point? Yeah. So we would just name it as 4, -4. Today you'll be doing these on paper. So this is all going to be on you. The points, the ruler, all this stuff is you. And you'll still have your delta math to do too. Any questions about that? Okay. Example number 2. Here is our system. Our first one is 4 equals -y minus 7/3 of x. And our second one is 14x equals -6y plus 24. Try to write a little smaller so I could keep the bigger graph. I like the bigger graph better. So let's talk about the guy on the left. There is a boss move here. What is it? I would go back and think in the same terms. I disagreed with Gunnar last time. Just in principle, I wouldn't have done it that way. But in this case, moving the y is super smart. Why? Because it's a negative, and I can really kill two birds with one stone. If I take this -y and I move it over there, that's a victory because it becomes a positive y. And then the only trade-off is that I have to take this 4 and move it over there. That's a simple swap, right? And what's nice is then you're just done. You don't have to divide or anything like that. So we wind up with a positive y on the left equals the -7/3 of x just stays. And what's gonna go after that? Negative, so -4. So that's Mr. Yellow, and he's ready to go. Okay, how about the guy over here? Sure, we could subtract 24. I would implore you again. I say this a lot, and I only get about 20% buy-in, but that's good enough for me. You would be very wise in a case like this to have this guy and this guy change places. Why? Because the y is negative. And there's a benefit to moving a y when he's a negative, because then he becomes a positive and we don't have to divide by a negative. So I am going to do it my way. I'm going to dig in my heels on this one and do what I said I was going to do. I'm going to take the red term and move it to the left. I'm going to take the purple term and move it to the right. Notice as I move things, I am changing their signs from positive to negative and vice versa. And then the 24 is just like whatever. He just watches. I love this because now when I divide, I can divide by a nice peaceful +6, right? So I'm going to divide everything I see by 6. Right here, right here, and right here. And I'm ready for my final answer. It is y equals what? You have a question? The 24? Because he never moved. It's a great question. He stayed on the right side, so he never had to move. The only reason the 6y changed is because he see that red arrow, how like he flew up over the equal sign. When something goes from one side of the problem to the other, that's when we change them. But if they don't have to move, then we don't change them. Good. Okay. So I'm sorry, what is the slope? It is. And then what's 24 divided by 6? +4. So this is Mr. Green. And you can already probably make an observation, but we're going to go through and do our due diligence anyway. So let's talk about Mr. Yellow. Where do we start our graphing journey? Thank you. Down 4. And what's his slope? Yeah, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, or 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. Grab your ruler, graph the line. That's that. Okay, how about Mr. Green? Where do we start the journey there? 2, 3, 4. Up 4? And what's his slope? Same thing, right? 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. Or 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. And you make the connection that these lines are, what's that word again? I heard it. They're parallel. So what can we say about the solution of this system?
No solution.
There is no solution, right? Okay, so when you graph two lines and they're going to be parallel, then you can just say, I got you. The answer is there is no solution. There is no set of X and Y that can make both of these equations true at the same time. This doesn't exist. Come in.
So we just have one.
Yeah, I struggle with that. I mean, I think it's always good practice to actually graph lines, but I think that's a good conversation that we can have. I think when we realize what's coming down the pike, it almost feels like a waste of time to graph the line. So let me think on that, okay?
So would you mind if we just like looked at it?
Do you mind if I just think on that for a little while? Thanks. I'll get back to you. Thanks. It's a great question. I don't think I mind, but I just want to ponder. I think it's having you practice graphing lines is never a bad thing, but there's something to be said for common sense also. Okay. Example 3. On the left-hand side of the curtain, we're going to have a nice simple negative y equals 3 plus 5 halves of x. And then on the right side, we're going to have 5x equals negative 2y minus 6. Left side, quick move. One quick move. What is it? Yeah, just divide by -1. Nice, simple, easy fix. Divide -1, -1, -1. And dividing by -1 is so easy because really all it does is change signs. It just makes things go switcherooski. No math. So what do I get? Y equals what? I'm sorry, negative 5 halves of x. And then what? Minus 3. I've been trying to kind of bully you into this for a couple months now, or at least a month, about we really should strive for that format. As you've seen with word problems, sometimes it's good to maybe do it the other way, but generally math people like it this way. Y equals mx plus b, not y equals b plus mx. Okay. How about the one on the right? What's our move there? Now we're talking, right? Maybe an old version of us would have said, let's add the 6 across, but maybe now we're starting to see that, you know what? This guy maybe isn't crazy after all. Let's move the red term over to the left and switch it, right? Because we're moving it. And then let's take the 5x and move it. But you'll notice, of course, that the 6 is going to stay as a minus because he's like, I'm not moving, dudes. So what does my next line say? Nice. Last step. Yeah, let's divide everything by 2. Observations? It's not only the same slope as the other one. Did we agree that this line and this line are identical?
Yeah.
To save a little time, because you don't like longer lectures than you need, you would agree, going back to JoJo's question, that since we know they're going to be the same line, why don't we just graph it once? Save a little bit of time, right? So let's go ahead and just, you pick green or yellow. They're the same. Where do we start the graph at? Down 3. And what's his slope? Right. Like this. And there really would be no sense in graphing twice because you would be just graphing on top of yourself. So in a case like that, I would just say graph one line. What do we say then is the solution?
Mhm.
That is right. We say that there are infinite solutions. Okay. Last one. This one. All right. Dude on the left. What's the move? I like adding the 2x this time because moving the y would only make him become a more annoying number, and I'm not about that. So I'm going to leave the y over here. but I am going to move this 2x across and make him become a positive because, well, he's jumping. When you're a hopper, you got to change. So he on the left side, I now get a positive 2x and a still positive 3. Last move, divide everything by 3, which leads us then to our final answer, which is y equals what? Done. What about this one on the right? Good. Now you're thinking math. Let's take the red one and move it. And then in honor of that, or in light of that, let's take the 9 and move it. It's not about whether y is on the left or the right. To me, it's about, can I get him to be positive? Like my life's just going to be generally easier. So on the left, I'm going to have a positive 3y. On the right, Aubrey, note that the negative 2x never has to move, so he's going to stay as a negative 2x. But note also that the purple 9 is moving back across, so he becomes a negative 9, right? Okay. You move him, you switch him. That's all there is to it. Last move. What do we get? It would be, I selected this problem for our last example because it would be really easy for someone to say that there's something significant about these. The fact that the slopes both have a 2 and a 3 in them is actually, in this case, completely irrelevant, okay? To be clear, there's just no significance to this at all. These are just going to be two boring lines that cross. So let's start with Mr. Yellow. Where do we start him at? Up 1. And what's his slope? Good. Bless you. Okay. Graph the line. How about Mr. Green? What's his slope? Right. And you grab a ruler, graph the line, see where they cross. That's it. I mean, we could do more, but the idea is if you are not good at getting Y by itself, you're going to struggle with this. And what sucks is that you're not struggling with systems, you're struggling with a skill from a month and a half ago. So if you're someone who has a hard time getting the Y by itself, let me know. I can generate tons and tons of extra practice for that. But all of this stuff we're learning is based on that. So like you have to be able to get Y by itself. All right, I'm going to hand out the next assignment. You're going to be doing either your Delta or the paper one. I don't care. They both need to get done. So it doesn't matter what order you do them in. Not a ton of workspace, but I think you can probably find enough open area there to make do. So for our first problem, number 1, for our first equation, what's the move? Yeah, I just moved the 4x because I like the 2y being a positive, so I'm not going to mess that up. So I'm going to leave the 2y over here so that he doesn't get mucked up. And then I'm going to take that 4x and move him across the equals, thereby making him become a positive 4x. The only thing that moved in this case was the 4x. So everything else stays. The 2y stayed positive, and then that -2 is going to stay as a -2, right? And then how do we finish this job? Right. We wind up with an answer of y equals 2x minus 1. So that one is ready to go. I might even go so far as to like put a box around it. I think I did that on my answer key when I made this. Like it's ready. So to graph him, I now just need to know the basics of y equals mx plus b. So I'm going to go down one, and then the slope is 2, which of course by now we know means up to right 1. And you always want to graph as many points or at least points as far away from each other as you can. And then you would grab a ruler. And you would graph the straight line that goes through those points. All right, one down, one to go. Now, as far as the other equation is concerned, um, I I think that one's actually in pretty good shape. Like it currently already says 2y. And what I'm going to do is I'm going to switch the 8 and the x, and I have to keep the negative on the x, so it's going to go with the negative x. And then I have to keep the 8 as a positive, so he's going to stay like that. You cannot switch 8 minus x and call it x minus 8. Just, I think you knew that, but I got to make sure we're clear. Okay. X has to stay with the minus belongs to him. And then what's the last thing we got to do to finish that little equation at the bottom there? Once again, we got to divide by 2. And I think that's it. So we get y equals, what's my slope going to be? There you go. Negative 1/2 of x. And what's my y-intercept? So plus 4. So this one also now can be boxed up. The things in the boxes are my prized possessions. Those are my equations that are ready for me to graph. So I'm going to start that one. Maybe I'll put a red box around this one just so that I can graph them in different colors. So that graph is going to start at up 4, and its slope is negative 1/2. The line, since it's negative, has to go downhill like that. So I'm going to go down and right, or up and left. And I'm going to graph the line. And the upshot again is, well, where do they cross? So clearly they cross right here. What's the name of that point? So the answer to problem 1 is 2, 3. Saying the answer is like 1% of the work, obviously. Getting there is the work, the hard part. Okie dokie. Well, let me know if you have more questions. So the first thing that catches my eye in problem 2 is that they both have these. And so for me, right away, that like raises a flag and tells me that I could get to my answer in one quick move if I just move the y's and make them positive and then clear any other stuff out of the way. So like on the first one, if I shoot that y across the equal sign, then he becomes a positive y. But the trade-off is that if I move y over, then the 8x is now in his way. So 8x has to shoot back across, and he becomes a negative 8x. And then the 4, that's the minus 4, just stays put like that. Are you? Oh, thank you for letting me know. Appreciate you. Does that make sense so far?
Yeah.
It's okay if you're going to ask about the graph. Don't worry, I'll show you. But like that's, yeah. So I mean, I had this question. I had this question a little while ago because what happens is we say like, how am I supposed to graph this? And I'll show you. Let's take a look at the other equation too. So I'll be right with you, Hammer. Okay, like 30 seconds is what I need here. So with the second equation, my thought process is the same. I would take that y and move it because moving it will make it be a positive. And when I move it over there, the trade-off then is that I have to move the 8x back across to get out of his way. So he becomes negative 8x, and then the 3 just stays like this. So let's talk about this first one, the one in the purple box, because I know there's a lot of people get a lot of stressed about this. So if I follow directions, if I go down 4, everyone's block on this problem is that you're telling me that the slope is negative 8. But I don't have enough room to go down 8 and right 1. So what we understand about slopes is that since we know the line's going to go like this, there's nothing stopping us from backtracking. And instead of going down and right, then we can just backtrack and go up 8 and left 1, and we accomplish our same objective. Slopes can always be doubled back. You want to go up and right, you can. If you want to go down and left, you can. Like every slope can be undone by going in the opposite direction. So this line is that. And then the other line is the same slope, but the y-intercept is 3. So I'm just going to go up 3 and then go down 8, right? That one I could go down and right because I had enough room. Does that help a little bit? Okay, good. So we would agree on that those are parallel lines.
Yeah.
Therefore, there's no solution. Hannah, what was your question? Huh? It is horizontal. Let's take a look at this. Everyone jump to number 6 or don't, but if you're interested, number 6. I anticipate there'd be a lot of questions about number 6. That top equation is funky. And, no matter how hard you try, those ones are still going to get us. What stands out about this is that there's no X, right? So the boss move, the smart move here is to take that negative Y and move it across to the left. And if you do that, he becomes positive Y. He takes the place of the 0. And we just get this Y equals 1. And then you know that a line that only has a Y is horizontal. So I'm going to just go up 1 unit and graph a horizontal line like that. So that is the graph of Y equals 1. And then the other one is just a normal line. Okay. I hope that clarifies for you. Anything else for the greater good? Okay, so remember after this, it is flex, but we are not going to flex today. We are all going to the gym. Okie dokie.